Determining enthalpy of combustion. You may be asked to evaluate an experiment. You'll be given the purpose of a lab investigation, and you'll be required to come up with an experimental design that details the experiment and method you will employ to satisfy the purpose. In preparation for this, your textbook has a number of lab-style investigations where the materials and procedures are given to you, but there are some labs that require you to develop it yourself. For instance, have you ever thought about how you would go about measuring the change in enthalpy of a burning candle? A simple calorimeter is not appropriate for combustion reactions. Energy changes in combustion reactions involve a lot more energy than those that occur in solution. The calorimeter materials will absorb enough of this energy to prevent us from ignoring it as insignificant, so the heat capacities of other materials should also be considered. This is a sample setup. Study it for a moment. Ask yourself what would be inside the vegetable can. It ain't vegetables. And why have it suspended by a clothes hanger wire? What is the purpose of the large juice can? What measurements would you need to make, and how would you make them, in order to gather enough data to determine the enthalpy of combustion of this candle? You should also know how to identify weaknesses in your experimental design so that they can be communicated when searching for sources of error to explain why your results are different from your predictions. For more precise measurements of combustion reactions, chemists use a special type of calorimeter called a bomb calorimeter. Reactants are ignited remotely in a reaction chamber filled with pure oxygen. The preciseness of the measurements rely on knowing the heat capacities of all the components of the bomb calorimeter. The manufacturer of the bomb calorimeter provides this information to the chemist by way of a single heat capacity value that has taken into account all of the components of the calorimeter that could be affected by the temperature changes within. Since the mass of water it contains as well as the masses of all the components is constant, there are no mass units in the heat capacity value, which is why it's called heat capacity and not specific heat capacity. Heat capacity has the symbol big C and units of kilojoules per degree Celsius. The energy released by the reaction changes the temperature of its surroundings. These are changes in kinetic energy, and so the kinetic energy formula is used. Where bomb calorimeters are concerned, masses are not considered, just the heat capacity of the bomb calorimeter and the change in temperature. Changes in enthalpy values derived from bomb calorimeters need to be corrected for because of their exposure to varying pressures. The isolated system of a bomb calorimeter causes changes in pressure as reactions proceed. In an open system, the pressure is constant. The enthalpy change in a bomb calorimeter is usually higher than the same reaction occurring under standard conditions.